use the design for example, in this case, a conformal cooling. You simulate it, you manufacture it, and you test it. And in this case, you were able to improve the mold temperatures by 30%. But not only that, when we compare to the original design using standard cooling, conventional cooling, you see how not only did the part temperatures change and we got more uniform cooling, but you look at the change in warpage and how it changed this angle over here in the part. And beforehand, if you measure the warpage at the tip here, was 14.6 millimeters, and afterwards it was 9.4 millimeters. And ultimately, when you expect better, you get better. Low expectations give you poor results. If you have higher expectations, ultimately, you can expect over time things to get better. Not just with the users, but also with the software. So it's also used to push the software developers to improve things. But we're often doing preliminary reports. We're reporting out gate locations. In this example on the right here, we're showing flow leaders and restrictors to affect the part design that need to be implemented back into the math data. But with the final reports, we're also putting in the TIS 3.1 specific items on a page-by-page basis. So at the end of this, I'll go through a quick report just to kind of show you what's involved in that.